Hello. Well, to start off, we were giving a couple numbers to start with. So at 6 p.m., which is the time that we found Mr. Fies in the classroom, his body temperature was already 80 Fahrenheit, 80 degree Fahrenheit. At 7 p.m., which is the time the police got to him, his body temperature had dropped to 75 degree Fahrenheit. And we're giving also that the temperature of the environment was 70 degree Fahrenheit. We did not know the time of death. So first of all, we had to calculate K from the Newton's cooling equation we were given of T of T equals temperature ambient plus temperature of the object minus the temperature ambient times e to the negative kt. After that, we plug in the values given, which leads us to 75 Fahrenheit equals 70 Fahrenheit plus 80 Fahrenheit minus 70 Fahrenheit times e to the negative k times 60 minutes, which is the time elapsed. After doing the calculation, first of all, we subtracted 70, 75. Then later we divided 5 by 10, which is the result after subtracting 80 by 70. After that, we did natural log in order to get rid of e. So we did natural log on both sides, and natural log of 1/2 equal negative 0.693. And on the other side, we were left with negative k times 60. The negative cancels, and so we were just left with dividing by 60. And 0.693 divided by 60 equals 0.012. So this number right here, what it represents is the decay coefficient for the death of Mr. Fies is k equals 0.012. Cool. That was part A. So for part B, what we did was, since we weren't given an original body temperature value, we assumed that his temperature was going to be like an average person's temperature. So we plug in 98.6 Fahrenheit equals 70 Fahrenheit plus 80 Fahrenheit minus 70 Fahrenheit times e to the negative k value that we already found, 0.012, times time, which we were trying to find the time elapsed since the time of death to the discovery time. We subtract 70 to 98.6, which gave us 28.6 Fahrenheit. Over here, we got 10 Fahrenheit from 80 minus 70. We divided that, and we were left with 2.86 Fahrenheit equals e to the negative 0.012 times t. We implemented natural log to get rid of e. Natural log of 2.86 equals 1.0508, which I just rounded to 1.051. And that equal negative 0.012 times t. We divided 0.012, and then it gave us an approximate of 87.568 minutes, which I then divided by 60 minutes to convert it from minutes to hours, and we got negative 1.5 hours, which it's an approximate for the time that has elapsed since the time of discovery to the time of death. So that led us to believe that Mr. Fies died around 4:30 p.m. And if our assumption was right that Mr. Fies had a starting temperature of 98.6 Fahrenheit, then the time elapsed we calculated should be exact. Because the body was found at 6 p.m.